Hello, wonderful person, this is Anton, and it's about time we've discussed the mysterious star Betelgeuse once again. And that's because we now have an official update in regards to its potential partner, which in this case is super exciting because it potentially resolves a major mystery about the star and explains why this star and a lot of other similar stars sometimes act just a little bit strange. And so in this video we're going to discuss this recent study by Montage and the team you see right here that was released a few weeks ago, discuss some other studies that expand on this idea a little bit more, and essentially talk about what exactly scientists have found here and why it's obviously kind of exciting. But I guess first, let's discuss the mystery that was bugging astronomers for quite some time. And so for over a century, astronomers were actually wondering if maybe Betelgeuse does have a partner that's hiding somewhere inside. But because decades of observations discovered nothing, and because most observations essentially just showed us one star, and a star without any planets, after decades of research, it was concluded to be a single object. But following additional observations from new telescopes, including the Very Large Telescope and the most advanced observations from the Hubble, researchers didn't just find the signs of this Beetlebuddy, or Betelgeuse's partner, they also discovered that this companion seems to be much bigger than predicted and seems to have major effects on the star. And interestingly, all of this started with the discovery of a very strange wake that seems to have proved its existence before anyone even found it. But the question is, so what exactly was this mystery about Betelgeuse that was just so difficult to explain without this partner? And to understand this, we first have to discuss how Betelgeuse basically breathes. In other words, how it changes its size and how it changes its luminosity, which by definition makes it a variable star. And so over time, its brightness changes, but usually following a predictable pattern, with astronomers basically observing two main heartbeats, or two main variabilities, referred to as the short period and the long secondary period. The short period is a cycle of approximately 400 days that's literally caused by the stars physically pulsating or expanding and contracting due to a lot of internal action. This is actually something that's extremely common to many different stars out there, with only certain stars being more stable and not actually containing similar pulsations. Turns out that the Sun is one of those stars. But there's also a secondary period, which is much longer and is almost 6 years long, anywhere between 2100 and 2200 days. And this particular cycle is actually a little bit more difficult to explain. As a matter of fact, for decades this remained a mystery, because only some large giant stars seem to contain similar long-term cycles. But initially it was believed to be the result of these massive convection cells, or basically these giant bubbles of hot gas rising to the surface of the star, that might happen every 6 years and thus change the luminosity of the entire object. But other scientists suggested that maybe it was just dust that seems to be emitted every 6 years, blocking the sunlight in the process. But then in 2019 and 2020, we basically had this very unusual dip when Betelgeuse suddenly dimmed by a huge amount. As a matter of fact, suddenly, in just a few months, it became barely detectable in the night skies, even though previously it was one of the brightest stars out there. And that of course led to this multi-year mystery, because everyone was now trying to figure out, so what could have happened here, and is Betelgeuse about to go supernova? But over time this was explained as a major emission of dust from the star that seems to have blocked the view, thus causing Betelgeuse to dim. Except that there was maybe one question that was still not really answered. What caused this unusual dust emission? Because here this was a huge expulsion, and it wasn't clear what could have produced it. Which basically meant that the mystery was not 100% solved. And it's really around this time that we now had this one potentially controversial explanation that a lot of scientists at first did not really consider. What if this long cycle and this unusual expulsion was not really the result of pulsation or internal bubbles, but instead the orbital period of a hidden companion star? With the idea being that there was a smaller star orbiting extremely close to Betelgeuse that would once in a while clear out or basically expel huge amount of dust from the environment, and well, one of these times it managed to do so with extreme ferocity. And so all of this light we see dimming from Earth and all of these brightening and dimming events every 6 years were basically just the result of the orbital period of a smaller object around Betelgeuse, with the object now being called Beetlebuddy. And though the hypothesis was obviously interesting, at first there was really no evidence at all, which is why not a lot of scientists considered it. But then we suddenly had our first clue. Prior to any initial images and prior to any additional observations, there was this very strange indirect clue based on some of the initial observations in the 1980s. And here Margarita Karowska used a technique referred to as speckle interferometry that at first started to hint that there were actually two objects and not just one. But back then the data was not accurate enough yet, and so it was just not conclusive, and not a lot of people considered it. But a few years back, we actually had some of the first breakthroughs from the Hubble Space Telescope. Although in this case astronomers did not see the star itself, they actually seemed to observe something that resembled a wake. So basically think of a boat moving through water, but in this case you don't really see the boat, you just see the wake. Or essentially you see the ripples that it leaves behind. And because Betelgeuse is a red supergiant, it essentially has an incredibly vast and diffuse outer atmosphere that extends way past the orbit of Jupiter, which means that if there is a wake, it's going to be enormous in size. And so here Hubble detected a dense trail of gas moving through the atmosphere, which in terms of shape and in terms of velocity did appear to be caused by some kind of an object moving through. And intriguingly, this unusual trail also seemed to appear exactly every 6 years, just like predicted if there was a companion crossing in front of Betelgeuse from our perspective. And so this bizarre wake now provided first clue in regards to an actual physical object interacting with the outer layers of the star. And so this was not just a computer prediction or some kind of a hypothesis, these were physical observations, which of course led to a lot of additional studies and potential predictions in regards to where the star is orbiting, how it's orbiting, and where we can maybe see it next if we wanted to physically capture the object and not just the wake. As a matter of fact, it's around this time that it now also received a name. It's now known as Siwarha. And well, now let's discuss the big news from the most recent study. The study that was just published in Astronomy and Astrophysics by a team led by Miguel Montage using the SPHERE instrument on the Very Large Telescope. Now here, in order to observe this and in order to see anything moving, we obviously have to use extremely sensitive devices. Scientists even compare this to basically trying to find a tiny firefly that's flying around an extremely bright lighthouse searchlight, but in this case trying to do so from several kilometers away, which means that they have to use very specific techniques and very sensitive devices. And here they used extreme adaptive optics, something that basically cancels out atmospheric blurring from Earth and tries to clear up the image as much as possible. And so here the team captured a point of light at an angular separation of approximately 52 milliarc seconds, which would be equivalent to seeing a tiny coin from about 10 kilometers away. And it's of course this point that seems to be the star in question. But interestingly, it seems to be different from what scientists predicted or imagined. Specifically, it seems to be just a little bit chubbier. Now, initially the model suggested that this is probably a star similar to our Sun in mass, or approximately 1 solar mass. Although in this case calling it a star is maybe a bit of a misnomer, because it was assumed to be some kind of a pre-stellar object, and an object that's not producing its own fusion just yet. But according to this new VLT data, it actually seems to be much bigger, possibly between 2.6 and 3.1 solar masses, essentially making this a B-type main sequence star, and being only about 5 to maybe 6 times less massive than Betelgeuse itself. And so because it is much more massive and much brighter than expected, this new data now officially confirms it with a statistical significance of 6.1 sigma. And while in astrophysics, anything over 5 sigma usually means that this is definitely an almost certain discovery. Here it's 6.1. So this is a very solid detection. But even this detection still contains some mysteries. For example, one of the strangest things about Siwarha is its orbit. It isn't just orbiting Betelgeuse, it seems to be orbiting inside supergiant's extended atmosphere, at a distance of only about 4 astronomical units, or 4 times the distance of Earth to the Sun, which creates some very unusual physics. For example, here scientists have always wondered why Betelgeuse was spinning so fast. Mostly because evolved stars like this one should actually slow down as they expand, but Betelgeuse was doing the opposite. Its spin is approximately 5 km per second, and to astronomers this was kind of difficult to explain. But the discovery of Siwarha suggests that the companion is actually physically spinning up this giant star through the action of gravitational tidal forces, with additional explanations even suggesting that there's maybe a chance that Betelgeuse actually ate another stellar object sometimes in the past. But because Siwarha is plowing through a very thick gas of Betelgeuse's atmosphere, it's physically losing orbital energy because of friction, with astronomers now predicting that in the next 10,000 years it will be extremely likely completely engulfed by Betelgeuse, thus becoming a physical part of the star. Now at this point we're not sure exactly what's going to happen, but there's maybe a chance that this will destabilize Betelgeuse and it might explode, producing a supernova. This is obviously not going to happen anytime soon, but it is definitely going to happen in the next million years. Although in this case, the presence of a companion will most likely produce a somewhat unusually shaped supernova, resulting in a supernova remnant that's not going to be spherical in shape. But at the same time, this confirmation is a lot more important for astronomy because it now solves so many mysteries at once. Specifically the mystery of these long secondary periods for many other stars and many other supergiants, because at least 30 of them seem to show very similar periods and seem to also produce these very bizarre dimming events that previously could not be explained. As a matter of fact, even famous stars like Antares and Arcturus very likely have these companions we haven't found yet as well, which in this case could be discovered by going through some of the archival data and by trying to take these extremely accurate observations with modern telescopes. Because in this case, this discovery was not made with a single photo, but was based on decades and decades of data collection, and by combining over a century of observations, which finally made scientists realize what's happening here. And so the discovery of Siwarha and the confirmation for its existence seems to mark a conclusion of a century-long quest. But also reminds us that even the most famous objects in the night skies, the ones we always believed we understood pretty well, can still hide a lot of massive surprises. But importantly here, the observations are not finished yet. As a matter of fact, the most important observation is going to happen next year around November of 2027. And that's because at this point, between November and December of 2027, scientists predict that this object is going to reach its highest separation from Betelgeuse on the other side of the star, which will provide us with the final confirmation needed for its existence, its mass, and possibly help us discover a lot of additional properties, which means that we'll probably come back and discuss Betelgeuse once again in the next few months. But until then, check out some of the previous videos on this topic in the description below, and watch out for that next video about the other dimming star mystery that we're going to be discussing really soon. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access and a few more things. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.